Hello everyone! Today we're going to be talking about the properties of radicals. We have to remember that a radical counts as an exponent, which means that when we're talking about PEMDAS or SADMAP, it comes in the E order of operations. Let's look at the product property of radicals. Okay, here's an example of a radical. We have to remember that if we have square root of 25x squared, another way of writing that would be 25x squared to the 1/2. This will be important later, so just hang on to that thought. The product property of radicals states that the square root of 25x squared is the same thing as saying the square root of 25 times the square root of x squared. So because it's multiplied on the inside here, we can separate that multiplication and make it into two problems. This makes it a lot easier to tackle. So for simplifying the square root of 25x squared, when we reduce it to square root of 25 times the square root of x squared, this quickly just becomes 5 times x, or 5x. In the same way we have the quotient property of radicals. The quotient property is really similar. So if I have, for example, square root of 25 over x squared, that can be simplified to say the square root of 25 over the square root of x squared. So when we look at it, we can see, 25 is being divided by x squared on the inside of this big radical thing. So we can simplify the inside before we do anything with the radical itself. So what I've done is I split it into two pieces, square root of 25 over the square root of x squared, which then becomes 5 over x. If you're wondering how I got x, let's go back to what we talked about just a minute ago. If I look at square root of x squared, that's the same thing as saying x squared to the 1/2. And when we're working with exponents, we remember that to simplify them, a power being raised to a power, you just multiply them together, and you get x to the 2 over 2, which is just x. So let's talk about simplifying radical expressions entirely. Let's look at this one. We have 375 times x to the 9th, all being square rooted. When we talk about simplifying a radical expression, what we want are a couple of things. One, there are no perfect squares inside the radical expression. And two, all variable powers are reduced as much as possible. Let's talk about what that means. Go ahead and take a moment, pause the video if you need to copy this down, and then I'm going to go ahead and do this problem and walk you through it. Let's talk about what I mean by no perfect squares. This number here is pretty big, so I want to make sure I know that it's simplified as much as possible and there are no perfect squares hidden inside of it. This is where you're going to need to remember all your perfect squares. So for example, 25 is a perfect square, 49 is a perfect square, 64 is a perfect square. Why? If you take the square root of each one of these, you get a whole number. So 5, 7, and 8. Okay, that means it's a perfect square. We don't want any gross decimals. So let's look at 375. Sometimes you're going to be able to look at it and immediately know that there's a perfect square. For example, if you just saw 49 inside the radical, that would be really easy. This number is a little bit more difficult. If you can't look at it immediately and know there's a perfect square inside of it, what I suggest you do is make a factor chart. I immediately look at it and I know that you can divide this number by 5. Okay, 375 divided by 5 is 75. I know that 75 divided by 5 is 15. Divided by 5 is 3. Now that I have all prime numbers here, I know that I can't go any further. But I remember that, 5 times 5 is 25. That's a perfect square. What I'm going to do is go over here, and I'm going to rewrite this expression instead using the product property as 25 times 15, so the leftover, and then I'm just going to leave x to the 9th. I'm not going to do anything with that yet. Okay, so I have 25 times 15. Great. Using the product property, I can then say, this is actually the square root of 25 times the square root of 15 x to the 9th. Going from there, I can say, well, I know the square root of 25, and for the purposes of this lesson, we're just going to be using the positive square root. We don't need to worry about negatives right now. We're going to go over here and say, okay, that's now 5 times the square root of 15 x to the 9th. So now I've just satisfied my first condition of simplifying. There are no perfect powers inside of this radical. Let's talk about the second condition, which was that the variable powers have to be reduced as much as possible. Okay, looking at it and remembering that I can rewrite this as 5 times 15 x to the 9th, all raised to the 1/2, I want to try and get this number here so that I can reduce it by dividing by 2. Okay, right now it's an odd number. However, I'm just going to rewrite that so I get an even number and an odd number. So I'm just going to subtract 1, and I'm going to get x to the 8th times x to the 1. Okay, I'm going to put that back. Okay, so you can see how I've split x to the 9th into x to the 8th and x to the 1. 8 plus 1 is 9. I did this because I want to get this number here to be an even number. This just kind of hangs out by itself. We don't do anything with this. Let's keep going. I'm going to rewrite it using the product property. So I'm going to split it into a bunch of different multiplication problems. I have 15 times x to the 8th times x to the 1. So I'm going to have 5 times the square root of 15 times the square root of x to the 8th times the square root of x. Okay, I don't write x to the 1 because it's just assumed if there's nothing written, it's just x to the 1. Okay, I've already simplified this as much as possible. 5 has already been taken out and reduced. Square root of 15 is not a nice number, so we just leave it like that. Square root of x is also not a nice number. However, this number here can be reduced because this is the same thing as writing x to the 8th to the 1/2. Because of that, I can say, well, 8 times 1/2 is just x to the 4th. That reduces the radical and gets rid of it. Okay, so then I just get x to the 4th. Okay, so when I rewrite it, what I want to do is make sure all the stuff that's not in radicals goes before. So remembering the product property, I know that this, which is now simplified with no radical, can go on the left on the outside of the radical. 5x to the 4th times all this other stuff that gets left inside the radical. So this is freed from the radical. This is now freed from the radical. This stuff remains. So we still have 15x on the inside. Just to review, let's do another one. The square root of 98 times x to the 5th times y to the 4th. Okay, let's go back to condition 1. There can't be any perfect squares inside of the radical. So I'm going to take 98 over here. I'm going to do my factor chart. Right away, I see if I divide it by 2, I get 49 on the inside. So let's just rewrite that. I rewrite it inside the radical as 2 times 49 times x to the 5th times y to the 4th. If I were to rewrite that with the product property, square root of 2 times square root of 49 times square root of x to the 5th times square root of y to the 4th. So I have square root of 2 times 7 times square root of x to the 5th times square root of y to the 4th. Because 7 is not in the radical anymore, it's been freed, we're going to put that on the left over here. 7 times all the rest of this stuff, which is still stuck in radical form for now. 2 times x to the 5th times y to the 4th. Okay, I'm going to rewrite the problem over here on the left because we still have 2 variables to tackle, x to the 5th and y to the 4th. We're just going to chop apart for now, and we're going to say, well, x to the 5th, how do we simplify that? We're just going to take this piece for now and worry about the rest of it later. We're just going to simplify the square root of x to the 5th part for now. If I want to make that into an even number, I have to say, okay, well, x to the 4th times x to the 1. Okay, let's rewrite it. 7 has already been taken out to the outside. Square root of 2, you can't do anything with that. That's not a whole number. Square root of x to the 4th times square root of x, we can't do anything with. Looks like square root of y to the 4th is already an even number, so we don't actually have to do anything with this. We don't have to split it. Square root of x to the 4th becomes x to the 4th to the 1/2. So we can just say that, 4 times 1/2 is 2. This becomes x squared. In the same way, y to the 4th becomes y to the 4 times 1/2, which just becomes y squared as well. Now that we've simplified that, we can go ahead and rewrite our expression with all the stuff that's been freed from the radical on the outside, and the rest of the stuff, this and this, we leave inside. So we're going to get 7 x squared y squared times, and inside the radical still, it's still stuck there, we have 2x, and that's it. Let's go back and check. There are no perfect squares inside of it, and the only variable powers on the inside have been completely reduced.